Today, we delve into one of the most transformative and rapidly advancing domains of artificial intelligence, NLP, or natural language processing. NLP is the field that allows machines to understand, interpret, generate, and respond to human language, whether that's text or speech. In simple terms, it's the bridge that connects human communication with computers and makes all our smart assistants, chatbots, and language models possible. Historically, NLP started with rule-based approaches, basically hard-coded grammar rules and massive dictionaries. While they worked for very controlled situations, they were rigid and couldn't handle the richness of natural language. Over time, we moved to statistical models that learned patterns from data, and today we rely on deep learning techniques using neural networks and transformer architectures. This shift is exactly what has enabled large-scale systems like ChatGPT and Google's Gemini to achieve human-like fluency. One of the first steps in NLP is tokenization. Tokenization is the process of breaking text into smaller pieces called tokens. These tokens can be words, subwords, or even characters, depending on the model. For example, a sentence like natural language processing is powerful could be split into words or into subword chunks like process and ing. Tokenization is essential because models don't understand raw text. They need these smaller, standardized units to process and learn from. After tokenization, we need a way to represent these tokens numerically so that neural networks can work with them. That's where embeddings come in. Embeddings transform each token into a dense vector in a high-dimensional space. The really powerful part is that these vectors capture semantic meaning. For example, words like king and queen end up close together in the vector space, and even analogies like king minus man plus woman approximately equals queen can emerge. This semantic representation is what allows models to understand context, relationships, and subtle nuances in language. One of the most popular applications of NLP is sentiment analysis, figuring out whether a piece of text is positive, negative, or neutral. But NLP can do much more: language translation, summarization, question answering, text classification, and even generating creative content. Whenever we analyze customer feedback, monitor social media mentions, or build conversational AI, we're using NLP behind the scenes. Today's most advanced language systems, like ChatGPT and Gemini, take all these techniques to the next level. They use transformer-based architectures with billions of parameters and are pre-trained on massive amounts of text data from the internet. These models are capable of not just understanding grammar, but also following instructions, performing reasoning steps, and generating text that feels deeply human. Instead of simply memorizing, they learn patterns and context, making them incredibly versatile. When it comes to speech, NLP works in tandem with ASR, or automatic speech recognition. Speech is first converted into text, then passed through the NLP pipeline for understanding and response generation. Finally, if a spoken reply is needed, the text output is converted back into audio using TTS, or text-to-speech. This is how smart assistants like Alexa or Google Assistant understand what you say and respond naturally. So why is NLP trending so much right now? With the explosion of large language models, generative AI, and user-friendly APIs, businesses and developers everywhere are integrating natural language capabilities. From chatbots and content creation tools to automated customer support and real-time language translators, NLP is powering a new era of human-machine interaction. To wrap it up, NLP allows AI systems to truly understand and generate human language. It relies on processes like tokenization, embeddings, and large-scale training on massive datasets. Whether you're chatting with a virtual assistant, asking ChatGPT to summarize a document, or dictating a voice note that gets transcribed perfectly, you're experiencing NLP in action. Thanks for watching! If you found this breakdown helpful, make sure to like the video, subscribe to the channel, and comment below if you want a deeper dive into embeddings, transformer architectures, or similar topics. I'll see you in the next one.